So yes, welcome everyone to the breakout room for the second UK AERIUS demonstration session, and thank you to those of you who came back from part one. Today we will provide an introductory demonstration on how to calculate the impact of industrial emission sources on habitat sites. And again, I'm pleased to be joined by Mark Wilmot, who is on hand to answer any questions that you may have about AERIUS. So this is the agenda for the breakout sessions. So we will work through an industrial source example. So calculating the impact of a new medium combustion plant development, and use this as an opportunity to provide additional detail on the user interface and how the tool works. So like last time, if you have any questions, please can you add them to the chat, and then depending on time, we'll answer them either here in the breakout room or back in the main room following the demonstration. So I will start by providing a very brief introduction to the tool, just in case there is anyone who couldn't join workshop one, and as well for the benefit of those watching the recording. So the UK AERIUS calculator calculates air quality impacts on protected natural areas. Models are used to calculate the air pollutant emissions, as well as the subsequent air pollutant concentration and deposition levels for various sectors. So, for example, you can calculate the air quality impacts of changes associated with a planned expansion or renovation of a farm, like we looked at in session one, or from traffic associated with a new residential area. And you can then export the results of the calculation and use them as part of your permit application or planning process. So, as I said, in session one, we looked at how to calculate the impact of an expansion of a hypothetical poultry farm in South Wales, and use this as an opportunity to provide a detailed run through of the user interface and how the tool works. And if you missed session one, a recording of the demonstration is available, and I would also recommend downloading the AERIUS Quick Start Guide, which provides a really useful and to the point PDF guide to the tool. So let's open the tool. Hopefully that should be open in my browser. There it is. So I have already entered my username and password, and this is the new home screen that you are greeted with when you log into AERIUS. And just to highlight again that there is a feedback button on the right, which when selected brings up this form, which can be used to provide feedback, ask questions, or raise a bug. So please do flag if you think something isn't working properly when you're using the tool. So if you provide your name and email, the help desk are good at getting back to you promptly with an answer or solution. And if possible, please attach a screen capture of your issue to speed up the process. So you just click choose files, attach your image, and this will help the team identify what may be causing your issue. You can also access the quick start guide that I mentioned previously by clicking that. It opens up for you. So I'm going to get right to it and import my pre-made GML file containing my model inputs. So here I am just going to click and drag the .zip folder from the files stored on my computer. So I'll just drag that in here. I'm pleased to see that there are no errors and no warnings after I've imported the file, which is great. As we are in the advanced import mode, which is selected here, you can see that my example contains one emissions source, 2 buildings, and 1 calculation job. Just to point out, a useful feature is that you can select which of these inputs that you want to import. So here I want to import the input files and create a new calculation. So I will just untick 1 calculation job. I want to add this as a new scenario, so I've got that selected in usage, and select a project scenario type. So this means that this is a scenario that we would like to assess the impact of and calculate the process contribution for. So for those of you that joined session 1, you will remember that when calculating the impact of our farm expansion, we included a reference scenario that was used as the baseline in the calculation of our process contribution. However, this time we are not entering a reference scenario, and AERIUS will therefore calculate our project contribution assuming a 0 baseline. So I'm just going to click import there, and it takes us through to the input screen. And we are greeted with the map of the UK. So I will open emission sources and double click, and it takes us to our project site. So we're located in North Yorkshire. So this is a hypothetical site, I must state, located in North Yorkshire and a couple of miles south of Middlesbrough. And I will zoom in further so you can see the detail of the proposed development layout. And I will also zoom out so you can see the nearby habitat sites. There we go. So you can see the North York Moors in the south there. So as I think I said last time, when you get a chance to have a go with the tool, I would recommend having a look at what is contained within the map layers menu, which is available in the right-hand side panel here. As there is some useful information available in here when looking at both our inputs and our results. So for example, if I wanted to see which SACs and SPAs are located near to the site, I can use the ecological sites menu and select an SAC. So you'll see this is an SAC, this one isn't up here. SPAs, you can see which of the sites are SPAs. I'll leave that on show all for the purposes of the demonstration. And I can also see which sites have features sensitive to NOx, ammonia and nitrogen deposition using the nitrogen sensitive habitats and species menu. So just move this over here. You can see which features are sensitive, and then they're color coded based on their critical loads, which is something which I find really useful just to scope out where my assessment is. And we can also use the measure tool to get an idea of which features are contained within our 15-kilometre formal assessment area. So it's just click and measure on the screen so you can start to get an idea of which sites are going to be included in our assessment. And the information tool is always really useful to access information for a specified point on the map. So this is both for your inputs and for your results. So the information tool is here, this question mark, and you can see if you just click, it brings up information. So where I clicked, we've got the North York Moors, and it gives you an idea of the habitats that are contained there and the respective critical loads and critical levels. So if we move on to preparing our emission sources, so we're going to model our project scenario in 2024. So I'm just going to update that here using the year menu and save that. So this will update which background concentration maps are used in the calculation and the vehicle emission factors that are applied when modeling roads. I prefer to have labels turned on. So if I just zoom in, you will see that our project site consists of a CHP block with our flue or point emission source and a nearby admin block, which is here. I'm going to switch to aerial view as there isn't much on the base map here. So to do that, I will go to base map and click aerial. So this gives us an idea of the sort of location where our source is being entered. And if by clicking on the source here, this provides us with an overview of the source parameters which I've already entered. So I'm going to click edit and click location. So just to recap from the first session, we have the ability to either enter a point, line or area source by selecting here. And we can either click and draw on the map or enter our coordinates directly here. In source characteristics, I've entered that we are modeling our stack as a point source. Here is where we tell the model that the CHP block is the primary building of influence on our emission source. So you can see I could also select the admin block if I wanted to there. We can select to use either a predefined or a custom diurnal variation profile, which I'll come back to in a moment. And I have added the other required parameters to calculate our emission source in the model. So, for example, the plant is operating using a 20-meter stack height, and we have added the temperature and the velocity that our emissions plume is being released at. If I click emissions, you can see that we have also manually entered our expected NOx and ammonia emissions in units of kilograms per year. So currently in the tool, the industrial emissions need to be manually entered. However, there is potential for the tool to be developed further to include preset industrial emissions information in much the same way that when we selected agricultural emissions in the last session, we had our scale emission factors preloaded in the tool. So you would just select those by clicking which sector your emissions, your source was categorized as, for example. And if I just click cancel to go back, you can see that our emissions totals are also handily summarized for our source here. So in this example, we have both NOx and ammonia emissions. So if I move on to buildings, we have two buildings included in our development. So we have our CHP block and admin block. Just to recap, that we can add either an area or a circular building. So building dimensions can be added either by drawing freehand, like I just did there, or the location coordinates can be entered manually if we know them in here, and we can also manually enter our building height or diameter if we're using a circular circular building, sorry. So our final scenario input is for diurnal profiles. So as you are likely to be aware, emission sources often vary with time, and therefore AERIUS can take into account diurnal changes in emissions for each of our modelled sources. So we can tell the model both how emissions vary across the course of a day, split into 24 hours, and across the week, so split into weekday, Saturday and Sunday. So let's add a new diurnal profile by clicking here. So we can either manually type our profiles into the table for a weekday average and for Saturday and Sunday, which will automatically update our graph here, or we can copy and paste in from our own CSV file into the raw input. So each of these 3 columns must add up to 24 as totaled as the bottom, at the bottom, sorry, and I will now import and show you my pre-prepared example. So it's just basically a CSV here. I'm just going to copy and paste the columns in and click import text input into profile, and you will see that the graph is automatically updated. I'll just rename this as workshop 2 and click save, and then that's saved in our diurnal profiles menu. So the example shows that our source emits at a certain rate between 9 AM and 9 PM on weekdays, shown by the orange line, and at a slightly lower amount between 9 AM and 6 PM on Saturdays, shown by the blue line, and we have 0 emissions on a Sunday. So that's just along the x-axis here. So we can then apply our emission source, our diurnal profile to our emission source by going emission sources, selecting the one we made earlier, click edit source. In source characteristics, we now select custom diurnal variation. We select our workshop 2 example, and you'll see we've our graph is replicated, and we click save, and then that's been applied to our emissions. So when we are happy with our emission sources and buildings, we have the option to add our own custom assessment points. So just to make the point again that these are optional, as the concentrations and deposition values will be automatically calculated for all of the designated sites located within that 15 kilometers of your emission sources anyway. And for a formal assessment, you therefore probably wouldn't use the assessment points option. But just to show you that you can click new assessment point and add them manually, or again type in the coordinates here and save that, or you can determine automatically. So I will select to automatically assign points for the nearest, let's go for 5,000 meters from our emission source. So the tool automatically adds points based on the shortest distance between our project and the designated site. So if I click define points and then add and then zoom out, there we go. We have a point at Langbar Ridge, 4 kilometers away, and Cliff Ridge within 5 kilometers of the site. So I will just delete those and run a formal assessment. So if we now move on to calculation jobs. So this is setting up our calculation. I will just rename this as workshop 2 so we can identify it later. Calculation method, we'll go for a formal assessment. Our assessment is located in England. Our project scenario is the medium combustion plant scenario. We don't have a reference scenario, so AERIUS will use a zero baseline. I'm going to select Manchester metadata just for the purposes of this demo. And just to note here that AERIUS is currently preloaded with metadata for the proposed case studies, and these will be expanded upon as the tool is developed. And I can then click calculate, and you will see that our results are now being generated. However, to save a bit of time, I have already run the model here. So in the results screen, we get a new view of our sources, which I'll just zoom into here. So here, they would be labelled with an R if they're in our reference scenario, or P if they're in our project, and therefore in this case both sources are shown as only being present in the project scenario. There is the option to change between the calculation jobs if you have more than one at the top here. In the scenario results, we can select which scenario we are viewing the results for if you have more than one. In result type, you can select to view with the scenario contribution, which is the calculation results directly from the model, or process contribution, which allows you to visualize the pollutant contribution associated with your project. So here AERIUS will automatically deduct the reference results from your project results. So I'm just going to zoom out so you can see how the results are shown on the site. So you can see that the graph aligns with what we're seeing on the map. And if I change that to process contribution, you'll see how it's been updated. You can use the pollutant menu to select whether you view results for NOx concentration, ammonia concentration, or nitrogen deposition. So I'm going to select ammonia here. You'll see how the map has been updated. And the most important results are shown for our chosen combination of scenario, result type, and pollutant in the white bar, and the tabs below the white bar present the results in a number of different ways. So there's a lot of information contained here. So as I mentioned, when a tab is selected, the data on the map will update with it, and results for NOx and ammonia concentrations are shown as points on the map. If I select deposition, results for nitrogen deposition are shown as these mapped hexagons. So just to recap, the deposition results are based on the average NOx and ammonia concentration within each of the hexagons, and they are then multiplied by a deposition velocity and conversion factor to determine the deposition amounts. So again, just to recap from our discussion in workshop 1, an average deposition velocity for each hexagon has been calculated based on a land use map and the deposition velocities recommended by the Air Quality Technical Advisory Group, or AQTAG. The percentage CL tab can be used to compare the process contribution to the critical level for NOx and ammonia concentrations, or critical load for nitrogen deposition of the most sensitive habitat feature associated within each of the sites. A good rule of thumb is that red and orange colours show the areas where we are above 1% of our CL, and you can find out hexagon specific info by clicking the question mark and then clicking on a hexagon. So you can see that now the information tool has been updated with our results here. So this is really useful if you're interested, if you want to investigate a certain point on the map. I also want to note that the total predicted environmental concentrations and deposition levels are also calculated for each hexagon or point on the map by adding the process contribution or in combination process contribution to the background pollution levels. We don't have this shown as part of this example. However, this will be shown in the upcoming in combination example when we're back in the main room. So I'll just show you how the critical level is shown for the North York Moors site here in the graph. In the distribution tab, so this can be used to view the calculation results in units of concentration or deposition, as shown here. The markers tab, so this can be used to quickly view the key areas, for example, with the largest increase in pollution levels. So as shown here, for example, the habitat and species tab. So this shows results summarized for the individual features within each site and comparison with the specific CLs, and finally summary, and provides a tabulated summary of the results, which I find quite useful here. And just to end with the export menu. So yeah, I think it's useful to note that your input files can be saved and exported as a GML file at any point in the process. So you just select what you would like to include and fill in your email address and click export. So exported files are sent to your email, and they're also available through the browser by clicking the link that's contained here, which is, really quick and a really useful way to download the files. And these can also be opened in GIS, which will be demonstrated again when we're back in the main room as part of the in combination example. So yeah, that's the end of this part of the demonstration. So I hope that was useful, and thank you for listening. Mark, are there any questions in the chat?
No, it's very silent in the chat, or at least in my chat, but I don't see any comments in the chat at this point.
Does anybody have any questions before we go back to the main room? Please feel free to unmute your mic or type them in. Well, thanks very much, Claire. Pleased to hear it.
You're welcome.
Tom, I feel like giving some feedback as well, because that was really good, and I think that hopefully we're all here still.
Thanks very much, Heather. Yes, I was.
Yeah, it was really good. Yeah, really good. And I mean, basically my thoughts as you were running through was I can't wait to get my login and actually kind of run through it, so that having this demo is really important. Having it recorded, I think, to be able to rewatch bits of it as well would be really, really good. And then just kind of like actually clicking on the tabs yourselves, and the being able to like click on the individual hexagons and see the breakdowns and stuff like that. I just think this is great. This is exactly what we need. So yeah.
Oh, that's really good to hear. So yeah, I'm in the position where I've learned this quite recently as well, and I think just with the quick start guide, excuse me, just have a drink. With the quick start guide, I was able to, quickly get to grips with the tool, and I think it's quite easy to teach yourself how to use it if you like. So you'll soon get to grips with it, I think. But yeah, the best way to learn it, I think, is to, as you say, have a go with it yourself and look around the tool, because in those map layers alone, I would find it useful to have those when I'm doing a HRA assessment, for example, and then let alone when we get to the results, being presented in such a useful way. So yeah, there is a lot of information contained in there, which is really good to see, I think.
Can I ask a really quick question, if there isn't anyone else kind of going stuff? So when you were going through, obviously, like the screen you've got sharing at the moment, on the left-hand side, you've obviously got that main kind of like menu bar, and there's the assessment points button. So when you're on that, so you mentioned that you don't really need to use this function because it's already going to have, when you run the calculation job, built into it the fact that we've got our screening distances and we want particular points on the protected sites. Did I get that right? You don't really need to use this one because it's kind of going to do it automatically anyway.
Yeah, so I mean, it depends what you want to achieve, I suppose. So what I meant from that is that if you click formal assessment, you can almost make it out. You get this 15-kilometer
okay
radius. So any sensitive sites within that, we get basically included in the model. However, if you wanted to use assessment points and put them in other places that you're interested in, or you're very welcome to do so. I think my point was more
there. Yeah, okay, cool.
Yeah, and it's and if you're doing, I think this determine automatically feature is probably good maybe for a quick look if you wanted to. I mean, it's really good at just saying as I say, it picks the shortest distance or the closest point of the habitat site to the source you select. So I think it could be potentially useful. But yeah, if you select formal assessment, it's all taken care of for you, really.
Yeah. Cool. Yep.
Yeah, I think, Thomas, just to follow up on that, so that the calculation points or assessment points are indeed for when you want to have like specific calculations for monitoring sites, for example. So if you have like monitoring locations, you can mimic those exactly in AERIUS. Or as Thomas said, like you can also do like if you don't know exactly which alternative, like you have multiple alternatives for your project. Either you can do the whole calculation for all the designated sites, or you just know the location, where the contribution is going to be the highest, or you expect the biggest change. You can just put a single or some assessment points there, and that will speed up your calculations quite quickly, and then you can assess which alternative should be preferable, and then do the full calculation for that one. It will just save you a lot of time.
So potentially it could be useful as a bit of a screening tool then, before going through to the full assessment.
The only thing exactly. But the difficult term with screening is that screening most of the time in the UK means that you don't do detailed modeling. So you will have a screening using detailed modeling. Because you will always run the full ADMS. So they'll give you a precise, air quotes, precise answer. It will give you the detailed model answer, but you can perform a quite quick calculation, because you limit the amount of points that need to be calculated by ADMS, and therefore it goes much quicker. And the same is that we're now working out together with CERC if we can even get a version of ADMS which the answer is a little bit less precise, but then takes way much less time to compute. So that could even be very cool Cool addition as well. So then that will be then more like a formal screening method, in which you can perform very quick calculations, and then do the full one when you have decided, okay, this is going to be my preferred alternative, and then you can do a full assessment.
Yeah, that would be really useful. Yeah. Okay. Thanks.
So I've just received word from the other room that they're just finishing off a discussion, and then we will be moved back.
Yeah, if there's no more questions, if you want to feel free to move back to the room now, and I'll let the other team know that we've gone there, and that should speed them up and joining us in the main room.
Fantastic, thanks, Jack. So yeah, it's just the return button in the top right if you don't know. Thank you.